Alrighty, so today we are starting our unit on trigonometry, on trigonometric functions. And since the beginning of this semester, we've been working on evaluating all these different types of functions, talking about the domain of all these different types of functions. That's how we're going to start with our trig functions. So we'll come back to them several times throughout the year and talk about different important features and characteristics and things that we can do with trig functions. But in this unit, we're going to introduce evaluating trig functions. Now, I know that in geometry, you saw some basic trig. You saw what we call right triangle trig. Who has heard or used or remembers the term SOHCAHTOA? Yeah, so that's the trig that you do in geometry, right? Use sine, cosine, sometimes tangent to talk about angles in triangles, specifically right triangles. We're going to start there for today, just to sort of refresh what you know, and then we're going to talk about what trig looks like in algebra. Okay, since we're not dealing with figures so much, we're not dealing with right triangles in algebra 2. How do we use these trig functions? What are they for? What do they tell us? Okay, so we can think of an angle, right? We're going back to angles. We still use these trig values. We're still going to use these trig values to talk about angles. The context is going to be a little bit different than in triangles like geometry, but we're still using them to talk about angles. In geometry, you talked about angles as being formed by two rays, right? Two rays with a common endpoint is an angle, right? Because we can keep extending these sides as long as we want. In our trig unit, anytime that we are talking about trig in algebra, we are going to talk about those rays as being an initial side and a terminal side. And what we want is for that angle to be in what we call standard position. So one ray forming our angle, we will call the initial side. And the other ray, we will call the terminal side. And then what we're going to do is we're going to talk about the measure of that angle as being a measure of the rotation from the initial side to the terminal side. So how far did I rotate from the initial side to get to the terminal side? And again, what we want is our ray to be in standard position, which means the initial side will be lined up with the x-axis. So I'm going to think of this as the x-axis. Okay. And then I want the vertex to be at the origin. So we're putting our angles on the coordinate plane. The vertex is at the origin, and that initial side is going to line up with the positive x-axis. Okay. Our terminal side, then, we think about sort of opening up to form this angle, a rotation to form an angle. That's going to be the orientation that we stick with. The measure of an angle, then, is the amount of rotation. Again, from the initial side to the terminal side. And we can talk about that rotation as being counterclockwise or clockwise. A counterclockwise rotation is a positive angle. If I had a, like what we see down here, a clockwise rotation, or if I drew my terminal side down here and this was my rotation, that would be a negative angle. No matter how far I take it, if I am measuring an obtuse angle, right, as long as it's clockwise, that's a positive angle, okay? If I took it all the way down to here, if I'm measuring counterclockwise, that's a positive angle. If I were looking at an angle that was right here, if I'm measuring clockwise, that is a negative angle. If I'm measuring counterclockwise, that is a positive angle. Okay. If the terminal side lies on an axis, you might see that called a quadrant angle. Otherwise, we're going to talk a lot about what quadrant an angle lies in. So I want you to remember our coordinate plane is divided into 4 pieces by the X and Y axis. The first quadrant is where X and Y are both positive, and then we label these in a counterclockwise fashion. So we'll talk a lot about what quadrant is this angle in. A lot of our work today is going to be on just recognizing what our angles look like. On the next page, sketch an angle whose terminal side is in the specified location, and then just give me a rough estimate on what that degree measurement could be. So let's say we're putting our angle on the y-axis. I'm going to draw my axes here. If I put my angle on the y-axis, initial side is going to be on the x-axis, and then my terminal side could look like that. If it's on the y-axis. Is that the only sketch I could have drawn? No. I also could have drawn initial side and terminal side. Either of those. Now, we talked about positive and negative. So if I let this be a positive angle, what would its degree measure be? 90, right? And we don't have to estimate on that one. That should be a 90-degree angle. Whoop, 90, there we go, degrees. What if I let it be a negative angle? How'd you get that? How'd you get negative 270?
Because it goes around the thing 3 times and a full circle that are 60 degrees.
Yeah, a couple ways that we can think about it. One, if I went all the way back to the initial side, that'd be a full circle, which we know is 360 degrees. So I'm doing 3/4 of a circle. That's 270. If you also said, well, 90 plus 90 plus 90, that would work too. Since we're going clockwise, that's negative 270 degrees. If I were to talk about this guy as a positive angle, that would be our 3/4 of the way around, which would be 270. Since 3/4 of the way around would be counterclockwise this time, that would be a positive. If we went back this way, that would be a negative 90 degrees. Let's sketch an angle that's in quadrant 2. That's in quadrant 2. Quadrant 2 would be over here. Initial side is along the positive x-axis always. That is how we orient our angles in standard position. That initial side is on the positive x-axis. And then to put it here in quadrant 2, you have a lot of options, right? You have almost 90 degrees of options, right? Just under 90 degrees of options. You could put it just past the y-axis. You could put it almost to the negative x-axis. You have a lot of room in there. For the angle that you drew, give me a reasonable estimate for the positive angle. Maybe 135, okay? 140, maybe yours is about 100. It's going to be somewhere between 90 and 100, right? Somewhere between 90 and 100. So whatever this angle is, it's going to be between 90 or 180, sorry. Somewhere between 90 and 180. Right? I want it in quadrant 2, so it can't be on the positive y, it can't be on the negative x. That means your angle somewhere, the positive angle somewhere between 90 and 180. What about your negative angle? Maybe 125. It's got to be somewhere between negative 180 and negative 270. Somewhere between. 225, okay. Give me a reasonable estimate for your angle. And then finally, an angle in quadrant 4. Quadrant 4. Let's see, let's get our initial side in here. And then quadrant 4 would be down here. Whatever your angle is for quadrant 4. Maybe it's really close to the negative y-axis. Maybe it's really close to where we drew the initial side. Okay. Our positive angle, again, counterclockwise, would be somewhere between 270, that would be on the negative y-axis, and 360, that would be if you went all the way back to the initial side. So somewhere between 270, there we go, and 360. Give me a reasonable estimate for your angle. And then what about the negative angle? It's got to be between 0 and 90, right? Got to be between 0 and 90. Give me a reasonable estimate for your angle. Maybe you're at about 30 degrees, maybe you're at 45, maybe you're at maybe 80, but it's got to be between 0 and 90, negative 90. So we just talked about a bunch of measurements in degrees, right? And that was what you used for most of geometry when you talked about angle measures for figures. You talked about degrees. You talked about quadrilaterals, how all their angles sum up to 360. You talked about interior angles for other types of figures, like maybe pentagons and hexagons, and you use degrees to talk about those things. You likely may have talked for only triangles about degrees in another unit of measure. That other unit of measure is something called radians. Does anybody remember talking about radians? I don't remember what they were, but I remember we said the word radians. Okay. We use radians pretty much exclusively when we talk about trigonometric functions in algebra courses. So in Algebra 2, in pre-calculus, in calculus, anytime we talk about degree measure, we're talking about radians, okay? So we can also measure angles in a unit called radians. We define a radian as the measure of a central angle that intercepts an arc that has the same length as the radius. So bless you, whatever the radius is, we're talking about an angle that cuts off an arc that's the same length as the radius. So if my radius is 5, this arc is also 5. Whatever that angle measure is a radian, okay? When we talk about radians, okay, we're relating the radius to an angle measure, okay? What arc would that be, okay, for a central angle centered at the origin. Okay, so we're talking about, if we think about our angles in standard position, here would be our initial side, our x-axis. Here would be our terminal side. We're talking about what is that measure. And we can split a circle up into some number of radians. It's not going to be an even number because we know circumference, right, is 2 pi times the radius. Right? Or maybe you worked with pi times the diameter, but the diameter is twice the radius. So we know it's not going to be an even number of radians for a circle. That's okay. Let's look at a couple of examples here, kind of working with the definition of radian. A circle has a radius of 6 and an angle. This is called theta. It's a Greek letter, kind of like pi. We use theta a lot for angle measures. So an angle theta that's positive in standard position that intercepts an arc with a length of 15. What's the measure of that angle in radians? So I can figure this out with a little sketch. We've got our angle in standard position. The radius is 6. And our arc that we're intercepting is 15. So that's going to be, I don't know, here somewhere maybe. There's our angle theta. And I know this arc measure is 15. What's the measure of the angle in radians? Well, 15 would be how many radiuses? How many radiuses could I fit into 15? 2, exactly 2? 2 and some change, right? This would be 2.5. So that angle measure is 2.5 radians. Unlike degrees, I often do not see the label radians when we give the measure of an angle. If it was 25 degrees, I would need to include the little degrees. If you see an angle measure and nothing, your measurement's in radians. A lot of times they drop the label. How about this guy? What's our measure of theta shown below? Give your answer in radians. So 2 would be how many of our radius? Our radius is 4. If our intercepted arc is 2, how much of the radius is that? It's half, right? It's half. So that's 0.5 radians, or half a radian. Mm-hmm.
I don't understand all the examples too. I don't understand like how you like do how big the 15 was.
Well, how did I know where to put the terminal side?
Yeah.
One answer is I've been teaching math for a long time and I know about where it's going to land. The other one is I'm looking at the radius is 6, right? So it's hard to take something straight and give a perfect estimate on where that curved piece is going to fall. But I know that the curved thing that I draw needs to be more than twice the 6. So I was looking at as I draw, and I probably should have put it farther down here maybe. I was looking at as I draw that curve, since I drew this to be 6, it's got to be more than twice that. So it's a rough estimate, okay? We're going to get into how should I know where an angle should go in just a couple of minutes, okay? So one thing that I bet you did do in geometry was convert between radians and degrees. Does anybody remember doing that, converting between? Does anybody remember how to convert between? Good for you. I'm going to go through a little review of that because it's something that you do one specific time in geometry and then not very often after that. But it relates back to circumference, like we talked about just a minute ago. So if I have the circumference of a circle, it would be 2 times pi times the radius. So a 360-degree angle, right, would be 2 pi times the radius. Okay, that would be just 2 pi radians if we're talking about the degree, right? It would be a little more than 2 full radians. Well, more than 6 because pi is 3 point something, right? 3.1415, blah, blah, blah. So if we talk about a 360-degree angle, that's 2 pi radians. To convert between degrees and radians, different people prefer different strategies. I like to think of it as a proportion. So whatever your theta is in degrees out of 180, we could think about that as our theta in radians out of pi. You could do, there's a whole process to get from the 2 pi r down to this proportion. But we'll stick with this proportion for for time reasons, we're going to be a little tight today. But this proportion. So if you know the degrees, you are filling in this. If you know the radians, you are filling in this guy. A lot of times in geometry, you think about divide by 180, stick in a pi, or take away the pi, multiply 180. You're going to end up doing the same thing with the proportion. I like the proportion because I have a spot to put whatever information I have, and I don't have to remember two different conversions. So if I want to convert from degrees into radians, we know the theta in degrees. So 30 over 180 equals the radian version over pi. I want to solve for my theta in radians. So that means I multiply by pi on both sides. And then we just reduce this. So 30 over 180 would be 1/6. So this would just be pi over 6. If I've got 270 degrees, that's 270 over 180 equals theta over pi. I want to solve for my theta in radians. So multiply by pi. 270 over 180, that would reduce to 3 over 2. So 3 pi over 2. You try C. Should have gotten negative 3 pi over 4. I want you to leave these as fractions. We'll talk about why in a little bit, but leave your radians in fractions. If we can convert degrees to radians, we can convert radians to degrees. Are there questions before I move on? Okay, we're just using that proportion. So if I can go one way, we can go the other. I'm going to use the same proportion. So this time I want degrees. So theta over 180 equals pi over 3 over pi. When I'm dividing a fraction by something, this would be pi over 3 times 1 over pi, which means we don't have pi anymore. We have 1/3. So I have theta over 180 equals 1/3. Multiply both sides by 180. And we get theta to be 60 degrees. I'm going to skip over B and go to C. This would be theta over 180 equals negative 5 pi over 6 over pi. We're going to get the same thing here where the pi's reduce away. And so we have theta over 180 equals negative 5 over 6. Multiply by 180 on both sides. And we get theta to be negative, this would be 30, so 150 in degrees. You try B. Should have gotten 90 degrees for B. Any questions on that one? Okay, so far, as we've been working in Radians, we've seen a lot of things that you guys have done already in geometry. I want to talk now about the algebra component of this, and it relates back to what we were talking about with those angles in standard position and our measure being a degree of that rotation. Okay, so the next thing that we're going to do is sketch a bunch of angles. So a few minutes ago, you asked me, how did I have a guess on where that angle might land? Because I've done the next thing that we're going to do a whole bunch of times. Okay. So when we talk about a full circle all the way around, that is 2 pi. Okay. All the way around is 2 pi. That's what we talked about up here, right? A whole 360 degrees is 2 pi radians. If I think about starting, I'm at 0. A quarter of the way up would be 90 degrees, right? Which is pi over 2. 90 degrees is pi over 2. 290 degrees, right? 2 of them would be 2 pi over 2. Does that make sense? Pi over 2 plus pi over 2 would be 2 pi over 2, or just pi, right? Pi over 2 plus pi over 2 would be 2 pi over 2, which is just pi. So 180 degrees is pi radians. If I go another 90, that's pi plus pi over 2. That's 3 pi over 2. And if I come all the way back, that whole 360 is 2 pi. Every time we talk about an angle on the coordinate plane in standard form, I know I start at 0. If I'm on the positive y-axis, that's an angle of pi over 2. If I go another 90 degrees, that's pi, right? If I end up on the negative x-axis, that's pi. On the negative y is 3 pi over 2. And all the way back, all the way around is 2 pi. Every time. Every time. So when we work on sketching where about should these angles go, okay, these are helpful little landmarks. So if I want to sketch angle theta and it's pi over 4, where should it go? What quadrant should it be in? It should be in the first quadrant, right? Quadrant 1, because 1/4, right? Forget about the pi for a second. If this is 0 and this is the half, a fourth is going to be right in between, right? So pi over 4 is going to be right in here. It should split that quadrant in half. This would be my angle, pi over 4. It should split that quadrant in half. It's halfway between 0 and pi over 2. If my angle is negative 3 pi over 8, negative means we're going clockwise. So 0, this would be negative pi over 2. This would be negative pi. Right? If I'm going negative, we're going down this way. Is this greater than or less than 1/2? It's less than. 3 over 8 is less than 1/2. So I know it's got to live in quadrant 4. Is it greater than or less than 1/4? It's greater than 1/4, right? So 1/4, negative pi over 4 would be there. We're halfway between 1/4 and 1/2. So this angle right here would be my negative 3 pi over 8. That's how I decide where to draw these angles. Okay? Fractions on the coordinate plane. Fractions on the coordinate plane. Pi over 3. I'm going to put my landmarks in here. This would be 0. On the opposite side, that'd be pi. So I'm looking at 1/3, right? 1/3 of this guy. I don't actually care so much about pi over 2 as the landmark this time, other than I know 1/3 should be less than 1/2. But I personally find it more helpful to kind of ignore that and divide the whole pi into thirds. Right? This whole guy is 1, so about 1/3, about 1/3, about 1/3. So we're looking at about right here. It's got to be more than pi over 2 or pi over 4. It's got to be more than 1/4, less than 1/2. Should be right here. Now these are rough sketches. I'm not getting out a protractor, right? I'm not measuring exactly. But I should have a pretty good feel on where these angles should live. I should definitely be able to tell what quadrant they're in. And I should have a pretty good feel on where in that quadrant they live. You'll notice the next page is all sketching angles, Okay, we're gonna do this a whole bunch. Okay, that's how we get better at it. That's how we learn. 3 pi over 4. 3/4, right? 3/4. So 0. This we know is pi over 2. This is pi. 3/4 should live in what quadrant? The second quadrant. It should live in the second quadrant. Right? It should live over here. It should be halfway between 1/2 and 1. 3/4 halfway between 1/2 and 1. So 3 pi over 4 is halfway between pi over 2 and pi. And then make sure that you do put in your angle for me, especially since we've got a few negatives in here. These are not all positive angles, so it's important that we note which angle we're talking about. Negative pi over 2. So we're going clockwise this time. Here would be 0. Here would be negative pi over 2. So we are looking at a quadrant angle this time, right on the negative y-axis. Five pi over 3. So here's 0, pi over 2, pi, 3 pi over 2. My denominator is 3, so I'm looking at thirds. So I'm just going to very lightly sketch in about where my thirds would be. My sketches are not going to be perfect. I don't expect yours to be either. But there would be 1, 2, 3 thirds. I want to go to 5 thirds, so I have to keep going. There would be 4 thirds. So this guy would be 5/3. Oop. Questions for me so far? The biggest idea here is number sense relating to fractions, right? Can I split things up into thirds or fourths or eighths? Yes, you can, okay? Negative 5 pi over 4. So negative means I'm going to go around this way. So here's 0. This would be negative pi over 2, negative pi. We're going to be just a little greater than negative pi, right? 5 over 4 is 1 1/4. So negative 5 pi over 4 is going to be 1 more fourth. I'm going to go to here. And since it's negative, that's a clockwise angle. Negative pi over 6. We're going clockwise again. So 0, negative pi over 2 would be here. Negative pi would be here. What quadrant will this angle be in? Quadrant 4. Quadrant 4. Okay. We know that from some of our other sketches, pi over 3, we're dividing into thirds, right? So this would be negative pi over 3. This would be negative 2 pi over 3. For a sixth, that's half of a third. Does that make sense, what I just said? A sixth, cut a third in half. So if I'm talking about negative pi over 6, that's going to be like here-ish. Positive pi over 6, what quadrant would that live in? Quadrant 1. Same idea as our 1/6, but this time counterclockwise. So if I thought about splitting up that first quadrant into 3 pieces, 3 roughly equally sized pieces, sort of, kind of. This first guy right here would be my angle, pi over 6. Three pi over 2. Where's that going to live? On the which y-axis? Positive? Negative y-axis. Good. That's going to be all the way down here. 3 pi over 2. Right? The more you do it, the easier it gets. 11 pi over 8. Is this estimate for me what quadrant we think we're going to be in? Quadrant 3? Quadrant 3? It's going to be more than pi, right? Because 11 over 8 is more than 1. So it's going to be more than pi. Pi is here. This would be 3 pi over 2. And this would be 2 pi. So 0. So we should be in here somewhere. Okay. 11 pi over 8. Sometimes for the, I like to go back to thirds and fourths. So if I have something like eighths, it's easier for me to think of it in terms of, is it more or less than 3/4 or 1/4, right? More or less than a half. So right here would be 8 pi over 8. To get to 3 pi over 2, let's see, this guy would be 16 pi over 8. So this would be halfway between those. That would be, what, 12 pi over 8? So it's going to be a little bit before our negative y-axis. I thought of it in terms of how to draw it. I would split this into fourths, and then we're 1 more piece this way. Should be right about there. And then don't forget to sketch in your rotation. Our last one, 7 pi over 4. What quadrant would that live in? Quadrant 4. Quadrant 4. This is almost all the way back to our x-axis, right? 8 pi over 4 would be all the way back, right? This is 2 pi when I come all the way around. This is 3 pi over 2. So I'm halfway between here. There's my angle. We're going to stop there for today. For tonight, I would like you to try problems 1 through 4 and 8 through 10 on page 6.